Hello, Mr. Burrell here. We're in Unit 8 talking about graphing. We just, in this last lesson, in this last video, talked about looking at a graph and identifying where that graph is increasing, decreasing, and where that graph has a maximum value or a minimum value. So those are some of the characteristics that we often like to look at when we're looking at graphs. Today we're going to talk about where a graph is positive, negative, and intercepts, specifically x and y intercepts. So, by the end of this video, this is what I hope that you're able to do, but what I hope you're able to understand. I'm hoping that you are able to identify where a graph is positive or where a graph is negative and identify the x and y intercepts of a graph. That's what hopefully we're going to be able to do at the end of this video. So if you have my guided notes, it might be helpful to have a colored pencil or a marker to use to mark the graphs in the way that we're going to here. So, I'm going to use my roller coaster analogy. I used a roller coaster analogy yesterday in this other lesson. So I'm going to use another roller coaster analogy. If you've ever seen this roller coaster, this is a roller coaster in Japan. It actually goes underneath the water, which I think is pretty cool. Like sprays water on you as you're going, and you go down into the water through a tunnel and then up back out of the water. So that's kind of the visual of the roller coaster that we're going to use to explain these different things here. So let me get access to my colors here real quick. Okay, so right here it says, with one color label, all the parts of the track where the cart is above the water. So right here, if I was envisioning this line right here as being the water, so my roller coaster is coming in and out of the water, I'm going to label all the parts of this track where the cart is above the water. So this is above the water, this right here is above the water, this right here is above the water, and this right here is above the water. So we did something very similar to this in the last video, but now instead of increasing and decreasing, I'm focusing on where the cart is above water and where the cart is below water. So next, I'm going to mark on my graph here all the places where the track is below the water. So right here is below the water, right here is below the water, and right here is below the water. Those are all the places that are below the water, where the track is below the water. Lastly, I'm going to put a thick dot every place where the track meets the water or touches the water. So right here, this might be that place in that Japanese roller coaster where they start spraying you with water. Right here, right here, right here. There's a bunch of them. A bunch of places where this track touches the water. Okay. So, now as I'm comparing this roller coaster to a function or to an actual graph, the colored part of this roller coaster function from number 1 represents where the function is positive. So everywhere I marked red, everywhere above the water line, or in this case, if I'm looking at this graph above the x-axis, everything above there I'm going to consider positive. The colored part of the roller coaster function from number 2 represents where the function is negative. So everywhere I marked in green that's below the x-axis, that is going to be negative. So everything above the x-axis is positive, everything below the x-axis is negative. Then all the thick dots that I put on this roller coaster function represent the x-intercepts. So if you ever heard the term x-intercept or y-intercept, an x-intercept is just where the graph intercepts the x-axis or wherever the graph touches the x-axis. So on all 6 of these occasions are x-intercepts because the graph touches the x-axis. And then this double star here at the bottom, the point where the roller coaster crosses the y-axis represents the y-intercept, and I'm going to mark that with a star. Couldn't think of a really creative way to explain that, but wherever the graph touches the y-axis, that vertical axis, I'm going to call the y-intercept. Okay, so I'm going to use this same roller coaster analogy in some of these other problems that I'm going to do here. So, for each of these graphs, I want us to identify the intervals where they are positive and negative, and then I want us to find the x and y intercepts. So I'm going to label both of these graphs at the same time, so I don't have to switch back and forth between my colors so many times. But in this graph, this is the part that's positive. This is the part that's above water. In this graph, this is the part that's positive or above water. And let me change colors here. This part right here is the part that's below the water, or negative. So I'm going to label all those. This is negative, the green, and red is positive. And then I'm going to put a thick dot on the places where I cross the x-axis. Right there, right there, right there, right there. Anytime I touch the water, I'm going to put a little star every time I touch the y-axis. And look right here, there's a star on top of a dot here. Okay. So, what we're going to do here, I'm going to define or write what the intervals are where this graph is positive. So if you notice, if I were to keep drawing this red line up into infinity to the left and up above, that's going to be above 0 or positive all the way from negative infinity all the way up to here. At this point, it's no longer positive. It starts going negative. So from negative infinity all the way up to negative 4, right there, is where my graph is positive. And also, right over here, starting at 2 and going on to positive infinity is also where my graph is positive. So from negative infinity up to negative 4, and from 2 up to positive infinity, that's where my graph is positive, or above water. Now for negative, where is the interval where my graph is negative? Well, this whole green section right here is negative, or underneath the water. That's from negative 4 up to positive 2. So from negative 4 up to positive 2, not negative 2, sorry, that was weird. From negative 4 up to 2 is where this graph is negative, or below the x-axis, below the water. Okay, now I'm going to identify my x-intercepts. Where am I touching the x-axis? Well, at x equals negative 4, and at x equals 2. So I'm going to write x equals negative 4 and 2. This is a negative 4 and 2. If I were writing what those points were, that would be the point negative 4, 0, and 2, 0. Those are the points where I cross the x-axis. Next, I want to find out what the y-intercept is. And this star right here is down where y is equal to negative 3. So my y-intercept is at y equals negative 3. Or, if I wrote that at as a point, it would be 0, negative 3, where x is 0 and y is negative 3. So that's how I write the intervals where my graph is positive and negative, and where my graph has an x-intercept and a y-intercept. So let's go here. On this graph, where are the parts of this graph that are positive? Well, this whole red section is positive, and that's going from 0 all the way to 4. So my graph is positive from 0 to 4. All these green parts are where my graph is negative. And if I keep drawing this graph down forever and left and right forever in both directions, I'm going to be negative all the way from negative infinity, so negative infinity all the way up to where x is 0. So I'm negative from negative infinity to 0, and then I'm negative again starting here at 4 all the way to positive infinity. So 0, 4, and then is for my positive interval, and the graph is negative between negative infinity and 0, and between 4 and infinity. Now let's look at my x-intercepts. So anytime I cross the x-axis, here and here is an x-intercept. So I have an x-intercept at x equals 0 and at x equals 4. It looks like 0, 1, 2, 3, 4. Yeah, 0 and 4. So those points are going to be 0, 0, and 4, 0. My y-intercept is anywhere I'm touching the y-axis. And notice right here, I'm touching the y-axis the same place I am the x-axis, at y equals 0. And that point is also 0, 0. So that's how I identify where this graph is positive, negative, and where the x and y-intercepts are. Let's do one more. So I'm going to move this right to the middle real quick. I want to do this one on the right. So let me get my red pen again. So I'm going to mark everywhere on this graph. Before I even look at the problem, I know I'm wanting to find the positive, negative, and x and y-intercepts of this graph. So I'm going to mark in red on this graph everywhere that the graph is positive or above water. And I'm going to mark everywhere on this graph where the graph is negative or below water. So this right here, I'm going to color it in right here. The graph is negative. So red is where the graph is positive, and green is where the graph is negative. So now I'm going to put a thick dot everywhere I touch the water, or every time I touch the x-axis. I'm going to put a star where I cross the y-axis right there. Now I am equipped to label the intervals where this graph is positive, negative, and where this graph has an x and y intercept. So this graph is positive from negative infinity, so from all the way over here, all the way to this point right here, when x is negative 7. So I'm positive all the way up to here. The other part of this graph where I'm positive starts right here at 4 and goes to positive infinity. So my graph is positive from the x values of negative infinity to negative 7 and from 4 to infinity. That's where my graph is positive. Now for the negative part, I'm going to look at this green section. Where am I negative? Where am I below the x-axis? So I'm below the x-axis, or negative, between negative 7 here and positive 4. So between negative 7 and positive 4, that is where my graph is negative. Okay, now I'm going to find the x-intercepts and the y-intercepts. Remember, the x-intercepts are where I'm touching the water, or touching the x-axis. So at x equals negative 7 and at positive 4, those are my x-intercepts. If I wrote those as points, it would be negative 7, 0 and 4, 0. Those are my x-intercepts. My y-intercept is wherever I'm touching the y-axis. So right here, that would be at y equals negative 3. This isn't a perfect graph, but it would be y equals negative 3. That point would be 0, negative 3. That's where this point would be. So that's how I identify intervals of a graph that are positive or negative, and then label the x and y intercepts. So this is what I hope that you're able to do at the end of this video. I want you to be able to identify where the intervals, specifically where a graph is positive, or the intervals where a graph is negative. And I want you to be able to identify the x and y intercepts of a graph. And just as a sum total of this entire unit, everything that we talk about with graphs, a lot of the graphs I've given to you have been pretty basic, pretty rendered, pretty artificial. But in the real world, depending on what you go into, maybe you go into business, or maybe you go into design, or maybe you go into engineering, maybe you decide to become a roller coaster designer. A lot of the areas that you go into in your professions, you'll have an opportunity to analyze data, often in the form of a graph, a graphical representation of something. And the tools that we have acquired in this unit about analyzing graphs and looking at how graphs behave and what graphs are doing, that's going to come in handy. So that's why we do this. This will also help equip us and prepare us for a lot of the stuff that we're going to do throughout the rest of this trimester. But I hope that was helpful, and I hope that you enjoyed it as much as I did.